Hello, and I received some questions about calculating distance between 2 points, specifically the ones on the IXL sheet. So as you can see so I just pulled some examples from the IXL practice, and there's this line right here. Write your answer as a whole number or a fully simplified radical expression. Do not round. So essentially what they want their answer in terms of a square root. And we never did that in class. So I thought, okay, well, why don't we do that in a video so that you get a sense of how square roots work and how you can manipulate them without writing it as a rounded decimal. So I picked a variety of difficulties. So some of these are going to come out as whole numbers. Let's try some examples and see where we're at. So in number one, we have to find the distance between 4, 3 and 7, 7. So again, if you're thinking about distance, right, it's that right triangle, right? If we have 2 points, right, and we have it on a slant, there is some rise and there is some run. And what this enables us to do is use the Pythagorean theorem to find distance. So think back to slope, right? Algebra 1, slope. If we use this whole change in y, right, remember that, and change in x, we can find the legs of this triangle or the two short sides. So let's try that. Change in y. So here are my y values. Remember, a point is x, y. X first because it becomes before y in the alphabet. So if I start with my y values, right, I have 7. Now, a change in y, if you think back to slope, is subtraction. So I'm going to write minus, a minus sign. And then I'm going to write my other y value, 3. Okay, so we have our change in y. And now let's do our change in x. So again, I'm gonna start with 7 minus, it's always minus, 4. Well, 7 minus 3 is 4, and 7 minus 4 is 3. And now we have our sides of our triangle here. So I can apply the Pythagorean theorem. So if I do 4 squared plus 3 squared equals c squared. So 4 times 4 is 16. 3 times 3 is 9. And 16 plus 9 is going to be 25. And now remember, in order to reverse a square, we have to use a square root. And I think that's where people are getting tripped up. So we have the square root of 25 is 5. And the square root of c squared is c. So the distance between these 2 points is 5. Let's try another example. In this example, we have to find the distance between -2 and 3, -2, 3, and 7, -9. So again, I'm going to do my change in y. So let's write it out like this, I guess. Change in y is going to be equal to -9 minus, and then I'm going to just write a 3 because it's my other y. Remember, points are x, y. Okay, that's change in y. Change in x is going to be 7 minus -2. See why it's important to always write that minus sign first? So now I have a negative, negative. It becomes a plus positive. So I have -9 minus 3. Well, that's going to be -12, right? Because I have negative and a negative, I'm going to add. And then 7 plus 2 is 9. So now if we apply the Pythagorean theorem, and I know in class we said make it positive, but this is technically what we're doing, right? So I'm going to take both of these values and I'm going to plug them into the Pythagorean theorem. A squared plus b squared equals c squared. And when I do that, I have negative 12 squared plus 9 squared equals c squared. So now I have a negative 12 times negative 12. Well, that's positive 144. So you get the same result. I think I was trying to simplify it in class by saying make it positive, right? 12 times 12 is 144. Well, negative 12 times negative 12 is also positive 144. So we get the same answer. And then 9 times 9 is 81. 144 plus 81 is going to be 225. And I happen to know this square root, but you have a calculator at your disposal, or Desmos is a good calculator as well. I happen to know that the square root of 225 is 15. Let's try another example. In this next example, we have to find the distance between negative 8 and negative 7 and 0, 3. All right, let's find the change in y first. We have 3 minus negative 7. Change in x is going to be 0 minus negative 8. Plus positive, plus positive. So here I'm going to have 7 plus 3 is 10. 0 plus 8 is 8. Let's plug our change in y, change in x into our Pythagorean theorem. So we have 10 squared plus 8 squared equals c squared. Well, 10 squared is 100. 8 squared is 64, 8 times 8. And 100 plus 64 is 164. So here's the problem. The problem is that 12 squared is 144 and 13 squared is 169. 164 is not a perfect square. And I think this is where you guys were probably getting wrong answers in IXL. I didn't realize that they had this direction here. They had this this piece here. Write your answer, the whole number, or a fully simplified radical expression. So this might be new. We didn't do this in class, but essentially what they want to do is they want us to break 164 down into its multiplicative parts, right? So if I'm thinking about 164, well, I know that I can do 2 times 82, right? So if I break 2 times 82, right? And now I know that 2 is a prime number. I can't go any further, so this becomes the end of that tree, right? But 82, we can do another 2, right? So 82 can break up into 2 and 41, right? Well, 2 is the end of this chain, and 41 happens to be a prime number. I don't know any numbers that multiply to give me 41. So now what we have is we have the end of our chain here, right? The rule is for every 2, so for every double, you take 1 out of the radical. So I look here, I got 1, 2, I got 2 2s. So I got 1 and I got 2 2s. If I have 2 of something under a radical, I can take it out. So I got a 2. And now I only have 141, right? And I can't break it up. So the 41 goes under the radical. And that's going to equal C. And this is what IXL wanted. IXL wants you to simplify radicals like this. You just think about what multiplies to 164, and you can make it work. So 2 times 82, and then 82 is 2 times 41. There are two 2's, so 1 came out. Let's try another example. So here I want to find the distance between -9 and 6 and -6 and 3. Let's find our change in y, right? So, I'm going to do 3 minus, and then the 6. Change in x is going to be -6 minus -9. Okay, we can add these up. 3 minus 6 is -3. We have a plus positive here, right? So I have a 9 minus 6. So that gives me a 3. Okay, let's plug it into a squared plus b squared. So I get -3 squared plus 3 squared equals c squared. Well, I mean, -3 squared is 9. 3 squared is 9. I have 9 plus 9, which is going to be 18. Right? We've got to take the square root. Here's the problem, right? So I know that 5 squared is 25, and I know 4 squared is 16. So it's going to be 4 point something, right? But we don't know what it is. We have to break this up into its multiplication. So 18, we know it's 9 times 2, right? We got 9 and 2. I know 2 is a prime number, so I'm going to keep 2 like that. And then 9 happens to be a perfect square, right? 9 happens to be 3 times 3. And I know 3 is also a prime number. So what I have is I have 2 3's, right? 1, 2 3's, but I only have 1 2. So I can take 1 3 out of my radical. The 2 has to stay under the radical because it didn't have a buddy to pair up with, right? And then the square root of c squared is c. So c is equal to 3 times the square root of 2. That's how you would say that. All right, we got one more example here. Let's give it a try. We have 0, 10, and -3, -1. All right, let's find our change in y. So I'm going to start with 10 this time. Put the minus sign, and then the -1. Right? Remember, it's x, y. Change in x. Oops. I didn't mean to do that. All right, so change in x. Well, we can start with either one. Let's start with the 0. Why not? Minus -3. All right. Now we got 2 negatives, right? Two double negatives, so we can go plus positive, plus positive. 10 plus 1 is 11. 3 plus 0 is 3. Right? We have our 2 legs of our right triangle here, so we can plug it into the Pythagorean theorem. A squared plus b squared equals c squared. So I know I have 11 squared plus 3 squared equals c squared. All right. Well, 11 squared, again, this is one I just happen to know is 121. But of course, use your calculator if you need it. 11 times 11. 3 squared is 9. You should know that one. And then 121 plus 9 is 130. Okay, we need to take the square root of both. And I know that 130 is not a perfect square, right? We know that 12 squared is 144, 11 squared is 121 because we just did it, and 130 is going to be somewhere between 11 and 12. But we can break it up into its multiplicative parts. So anything that ends in 0 is divisible by 10, right? So we have 10 and 13. Well, lucky for us, 13 is a prime number. 10 is not a prime number, but I can break 10 up into 5 times 2. 5 is a prime number. 2 is a prime number. But we have a problem, right? We've reached the end of our stem here, right? We have nowhere to go. I can't multiply 5 by anything, 2 by anything, or 13. I can't break those up, right? No one has a partner. There are no doubles here. So I can't pull anything out of the radical. Therefore, the answer is square root of 30, with square root of 130. And of course, the square root of c squared is c. So I hope that this helps you understand radicals a little more about like what exactly is going on here, and the distance formula calculations as well. So if you have any questions, feel free to email or bring them up in class.